In this video, you will learn about anomaly detection in PyCaret. We will use a dataset from UCI called mice protein expression. You can get the dataset on Kaggle. If you come to Kaggle, you will see the dataset is here, mice protein expression, and you can read about the dataset here. The dataset consists of the expression levels of the 77 proteins modifications that produce detectable signals in the nuclear fraction of cortex. The dataset contains a total of 1080 measurements per protein. Each measurement can be considered as an independent sample of mouse. The goal is to identify a subset of proteins that are different between the classes. Let's load the dataset first. From PyCaret dot dataset import get underscore data. This function will help us to get the dataset. I'll make one variable dataset. I'll use this function get underscore data to load the dataset in our variable dataset, and we have to provide the dataset name here, and the name is mice. Let's execute our code. It will download the dataset on our Jupyter notebook. It can take up to 1 minute. So the dataset is downloaded here, and you will see we have all these columns, mouse ID and all these other columns. These are the column names, and here the goal is we have a variable class. We want to detect the anomaly in this class variable. We will classify this class variable as anomalous and non-anomalous, and that will be done on the basis of this variable class. So some of this observation will go to the anomalous section and the other will be non-anomalous. Let's split the dataset into train and test. For training, we will use 95% of the data, and for testing, we will use 5% of the data. So I'll make one variable first, and that variable will contain training data. I'll make the variable data underscore train. From dataset, I will use the method sample. This will give us the random sample, and we want to use 95% for training. I'll pass one parameter fraction frsa, and here I will write 0.95. So it will take 95% of the samples randomly and assign to this variable data underscore train. The next parameter is random underscore state, and you can give any number here, and as per the official website of PyCaret, the number is 786. So I'll type here. Let's execute our code. Let's check the shape of our training data set. So I'll write data underscore train dot shape. In our training data, there are total 1026 samples and 82 columns. We will also check the shape of our original data set. I'll put a new cell here, and then I will call our variable dataset dot shape. Total there are 1080 samples and 82 columns, and for training we are taking 95% of the data, and 95% of data contains 1026 samples. Let's look at the head of our training data. I'll copy this name from here and paste it here, dot head. In the output, you can see the head of our training data set, and one thing you will notice that the indexing are not in the proper order. We have 700 series, then 100, then 500. We have to reset the index. We will do that. First, we will assign the 5% of the data for the testing. I'll make one variable data underscore test. Then I will call our original data set, and then I will call the method drop, and I will call data underscore train dot index. Here I am saying that from our original data set, drop all those samples which have already been assigned to this training data set. So 95% of the samples will be dropped, and the remaining 5% samples will be assigned to this variable data underscore test. Let's execute our code. Let's check the shape of our data underscore test. In test data, we have total 54 samples and 82 columns. Let's also look at the head of our test data set, data underscore test dot head. And these are the top 5 rows of our test data set. Here also you will see that the indexing are not in the proper order. We have to reset the index. Let's reset our index for both train and test data. First I will call our training data underscore train, and to reset the index we will use the method reset underscore index, and I'll pass one parameter drop is equal to true, in place is equal to true. So this function will take place on our original data frame, data underscore train. Let's execute our code. Now let's look at the top 5 rows of our training data set. Here I have to type head and then parenthesis. So you can see now the indexes are now in the proper order. We have indexes starting from 0, 1, 2, 3, 4. We will do this for test dataset also. I'll copy this code from here. I'll paste it here. Now instead of data underscore train, I will call here data underscore test. Let's execute our code. Let's look at the top 5 rows of our test dataset. I will call this variable and head. In the output you can see we got the indexes in the proper order for the test dataset also. So we have reset the index for both train and test. Next we will set up the environment. Setup function initializes the environment in PyCaret and creates the transformation pipeline to prepare the data for modeling and deployment. Setup function must be called before executing any other function in PyCaret. So before you build any model, you have to call this setup function. We will initialize the setup function now. From PyCaret dot anomaly import star. Star means we are importing everything. I'll make one variable anomaly 1, and I will call the setup function setup. Then the first parameter is data. We have to provide the data here. We will pass our training data set data underscore train. The next parameter is normalize. We will set it as true because we want to normalize our data set. The next parameter is ignore feature, ignore underscore features. So in ignore features I will put this column. The next parameter is session id, and you can put any number here. This is similar to seed function in Python. This is for the reproducibility. I'll write number 1 to 3. If you want your result to be same as mine, then you also have to put this 1 to 3. Otherwise you can put any random number here. And let's execute our code. This will take some time, 1 to 2 minutes. So we got this error here because we have to put this mouse ID in a list here. I'll make a list. Now let's execute our code again. This is processing, and you will get one message here. Following data types have been inferred automatically. If they are correct, press enter to continue or type. So these data types are correct because this is the inbuilt data set of PyCaret and all the features are correct. That is, the first one is numeric, second is numeric, and so on. All these feature types, the data type of features are correct. That is why I am going to press enter here. And once I press enter, I will get this message. Here you will get the session ID 1 to 3, the original dataset 1026. In training dataset, there are total 1026 samples, which we can verify. And if we call this training data shape, you will see here 1026 samples are there in the training data 1026. So that is why here we got the original data as 1026, missing values too. So there are missing values in this data set. And numeric features, there are total 77 numeric features. There are 4 categorical features, ordinal features, false, and so on. We will get all the information about the data set once you run this setup environment. We have done the setup environment. Next we will create the model. Let's create a model now. The anomaly detection model in PyCaret is created using the function create underscore model. We will use the algorithm isolation forest to create the anomaly detection model. I'll make one variable iForest, and then I will call the method create underscore model. This function is used to create model in PyCaret, and inside this I will type iForest, the algorithm name. Let's execute our code. This is processing. It has finished processing. Let's print our object iForest, print iForest, and here we will get the hyperparameters of the algorithm iForest. We have hyperparameters such as behavior, bootstrap, then contamination 0.05, maximum features 1.0, maximum samples auto, number of estimators 100, and jobs -1, and so on. These are the hyperparameters. We can also change it, but for this tutorial we are going to use this default hyperparameters. Now in PyCaret there are total 12 anomaly detection models are available, and they are ready to use. To see the complete list, we have to call the function models. So I'll call the function models, and this will give us the list of 12 anomaly detection models which are available in PyCaret. Let's execute our code. In the output you can see all these. This is the id. We have the short form, then we have the actual name of the algorithm, and this is the reference where you can find the more information about this. So we have anomaly detection algorithms such as angle based outlier detection, clustering based local outlier, isolation forest, k nearest neighbor detector, local outlier factor, and so on. And these are the short forms. So whenever you want to develop any algorithm, you have to give the short form. You don't have to type the full form of the model name. Once you type the short form, then the PyCaret will build that model for you. Next, we will assign a model. Now that we have created the isolation forest model, you can see here that we have created the iForest model. We will assign this model. I'll make one variable iForest underscore result. I will call the method assign underscore model, and then the model name which we have created above, iForest. Let's execute our code. Let's look at the top 5 rows of our iForest results. So I'll copy this and paste it here, and then I will call the method head, and in the output you will see we got a data frame here, and we will get one new column. So we got a new column here. We got two new columns here. We have one anomaly, and the next column is the anomaly score. In column anomaly, we have two numbers 0 and 1. 0 stands for inliners, that is not anomaly, and 1 stands for anomaly or outliers. So this anomaly column will contain two values 0 and 1. 1 is anomaly and 0 is not anomaly. In column anomaly score, the score is the values computed by the algorithm. Outliers or anomalies are assigned higher anomaly score, and normal data points are assigned lower score. So all these anomaly data will have a higher score, while the non-anomalous data will have a lower score. Now let's plot the model. So till here, I hope you understood. We have created our iForest algorithm here, and then we have assigned that to we have assigned the result to a new variable iForest result, and in that we have found that we got two new columns. One is anomaly and the second is anomaly score. So we will get here whether it is anomaly or not. 0 means not anomaly and 1 means it is anomaly, and we will get the corresponding score here. Next we will plot the model, and to plot the model we will use the plot function, plot underscore model, and we will type our model name. So our model name is stored in iForest. Here you will see, here you can see this is our model iForest. So we are passing the model name here. Let's execute our code, and this will plot the iForest model for us. It can take up to 1 minute depending on your computer speed. So it has finished processing, and this is the plot for the outliers. You can see it's a very beautiful plot. And can you guess what this blue and yellow dot represents? So I'll tell you. All these yellow point represent this is anomalous. All these are anomaly points, and the rest blue are the normal data points. And for each yellow, we got the, you can see the, if I hover on the yellow color, anomaly is equal to 1. You will see here anomaly is equal to 1 written. Then we have the feature, and we have these 0, 1, 2 also. And if I put on the blue one, anomaly is equal to 0, then we have feature, then 0, 1, 2. So all these yellow dots are anomalies, and the blue one are the normal data points. Next, we will do some more plots. We can also make uniform manifold approximation and projection plot, that is UMAP. We will write plot underscore model, and we will pass our model name iForest, and we will pass one more parameter, plot type, and plot is equal to, the type is UMAP. Let's execute our code. This is our UMAP plot for outliers. You can see here all the yellow dots are the outliers, while the blue dots are not anomaly, and yellow dots are anomaly. We will make prediction and save in a variable. I'll make one variable test underscore predictions. Now I will call the predict method predict underscore model, and here I will pass our model name iForest, and the next parameter is data. We are going to make prediction on the test data set, so I will pass data underscore test. This is our test data. Let's execute our code. So we have made predictions and saved in this variable test under predictions. Let's look at the top 5 predictions. I'll copy this variable name from here, paste it here, and type dot head. In the output, you can see we got the data frame of top 5 rows, and here we will see the predictions. And these are the predictions for our test data set. So it has classified this observation, the observation number 4, as anomaly, and you will see here that the all the anomaly score here, you will see we have 0, 0. These are not anomaly, and the scores are in negative, because the data points that are not anomalous will have a low score, and these are having low score. The scores are in negative numbers, and this data point is anomalous, so it has a high score. It has a score in positive, and you can see the difference here. The anomaly data will have a high score, and the non-anomalous data will have a low score. That is why all these score are in negative. Now let's save our iForest model. We can save this model in our machine, and for that we will use the method save underscore model. Inside this, we have to pass our model. Our model is iForest, and then we have to give the model name, and let's give it as iForest model, and this will save the model on our disk. Let's execute our code. So we have saved the model, and you will get an information here, transformation pipeline and model successfully saved. That means the model has been successfully saved on your machine. Now we can load this model back to our Jupyter notebook and make prediction. So let's load our model. I'll make one variable saved underscore iForest, and in this variable I will load the saved model, and to load the model we have to call the method load underscore model, and inside this we have to pass the saved model name, and our saved model name is iForest model. So I'll type this here, iForest model. Let's execute our code, and you will see a message here, transformation pipeline and model successfully loaded. Next, we will make prediction using this saved model. I'll make one variable new predictions, and then I will call the method predict underscore model, and this time I will use this saved model which we have loaded now, and we have saved this model in the object saved underscore iForest. So I will pass this object saved underscore iForest, and we will make prediction on the test data. So I will provide the parameter data is equal to data underscore test. Let's execute our code. So we have made prediction and saved in the variable new prediction. Let's look at the top 5 rows of our new prediction. We will type head here. Let's execute our code. In the output, you can see we got the top 5 rows, and let's look at the anomaly and anomaly score here, and you will see we got the fourth observation as anomaly. It has a score in positive while all these other observations are normal and the score are in negative. And we got the same result here also because we have saved our model and then we have loaded that same model and we have made prediction using the same model. That is why we got the same output here for the test data set. The purpose was to tell you that you can save your iForest model on your disk, and whenever you want you can use this in future. And this is how you can make the anomaly detection model in PyCaret. I hope you enjoyed this video. If you like my video, please subscribe to my channel. Thank you for watching.